Okay, everyone. Welcome to this research seminar with Anandi, Hattiangadi. Anandi has been a professor at the philosophy department at Stockholm University since 2013 and is a researcher here at the Institute. She earned her PhD in philosophy at Cambridge University in 2001 with the dissertation Oughts and Thoughts, Skepticism and the Normativity of Content. She has worked in many places, for example, University of Toronto, University of Cambridge, University of Oxford, and has also been a Pro Futura Fellow at SCAS in Uppsala. Anandi's research spans the philosophy of mind and cognitive science, philosophy of language and logic, philosophy of AI, epistemology, metaphysics, and metaethics. So very broad competence. So some of the recent publications include Do Large Language Models Understand Natural Language? And The Outputs of Large Language Models Are Meaningless. Today, Anandi will talk about, or she will present a manifesto about artificial general intelligence. Welcome.
Thank you very much. I should start with thank yous to all of you for coming to listen to my talk and all the people online as well. Also, thank you to the Institute for inviting me here and for hosting me. It's a wonderful environment to be in. And I'm delighted to be able to talk to many of the people who sit at desks close to mine. I also need to thank the Wallenberg Foundation for funding this project. The work that I'm presenting here is partly funded by a project by them called Cogito Machina, and it's on artificial general intelligence. I should also say that the work that I'm going to present here is coming out in a book with Cambridge Element series, which is going to be called Artificial General Intelligence, a Manifesto. So to start, right now, experts in artificial intelligence and tech industry insiders are predicting the imminent emergence of artificial general intelligence. That is to say, machines that are at least as clever as humans, in some sense. Some people have even claimed that they've moved beyond developing artificial general intelligence. For example, Mark Zuckerberg, the CEO of Meta, has claimed that they're already working on superintelligence. That is to say, machines that are even more, significantly more intelligent than humans across the board. And right now, there are billions and billions of dollars being poured into the development of AGI. The optimists, right, all the people who are spending all this money, they're hoping that an AGI, a machine that's at least as intelligent as a human, is going to solve all of humanity's problems, right? Put an end to war, eliminate disease, prevent climate collapse, or at least figure out how to do so. If not, then maybe they're hoping such systems will make them a lot of money. But at the same time, there is a vociferous group of AGI, one might call them doomsayers, who fear that AGI will spiral out of control and ultimately threaten the existence of humanity. So it seems to me that these prognostications are fueled by technological advancements in the design of AI systems over the past few years, right? It wasn't that long ago that AGI was just the stuff of science fiction, but it's only recently that these systems have become really powerful that people have started to think that maybe we're seeing the sort of sparks of AGI. So one example of this is Google DeepMind's AlphaFold 2, whose developers received the Nobel Prize in Chemistry in 2024, which is an artificial system that's able to predict protein structures from amino acid sequences and other sorts of data as input with incredibly high accuracy. And these structures are very difficult to predict using other methods, so this kind of technology has the promise to have some kind of really profound significance for our understanding of structural biology and also the development of medicines that can cure diseases, perhaps like Alzheimer's, and various others. But the thing about AlphaFold is that it is what's called a narrow AI. So it has, in a sense, superhuman capabilities in predicting protein folds, but it can't do anything else. It can't reason, it can't play chess, It can't do any of the other things that a human can do. So, but the big bump in confidence in the prospects of AGI came when OpenAI launched ChatGPT, especially the GPT-4 model, which is the sort of brains. It's called a large language model, or LLM, that is the kind of brains behind the chatbot ChatGPT. And since then, we've seen many, kind of proliferation of these models. There's Google's Gemini, Meta's Llama models, DeepSeek, xAI, and Mistral AI. So the thing about these systems is that they're incredibly fluent at processing natural language, such as English or Hindi or Swedish. They can write poems, they can write argumentative essays, and they can write literature summaries that are better than many undergraduates. So the fact that LLMs are so proficient in using language is, I think, an important reason why people think that they're on the path to AGI. Because, at least until now, using language has been the province uniquely of humans. No other animals on the planet have developed such sophisticated systems of communication. Animals have signaling systems. They are able to communicate in a certain way, but it is extremely limited. And for decades and decades, people have tried to teach our closest cousins among the apes to speak and understand and communicate in human languages. And generally speaking, there are some very, very striking limitations in the abilities of even bonobos to do so. So they rarely surpass, or they never, I think, surpass the abilities of approximately a 2-year-old or 3-year-old child. And what's more, I think, this has been in the air for a long time, right? Because when you think about it, Alan Turing, who's one of the pioneers of artificial intelligence, he used language use as a kind of gold standard for understanding or for having a mind. So he said we should replace the question whether a machine could think with the question whether a machine could pass what he calls the imitation game, in which a computer has to fool a human judge into thinking that it's human by engaging in some conversational exchange. This has come to be called the Turing tests. And of course, once ChatGPT came out and all these LLMs came out, people started saying things like, they've broken the Turing test, right? The Turing test no longer applies because they're just so fantastically capable with language. And then, there's been further developments, right? People claim that they score highly on benchmarks that are supposed to measure not just fluent language use, but reasoning, coding, solving math problems. Then when they're combined with other systems like image processors, like DALL-E 2, for example, they can do things like categorize or translate between text prompts and images. They can summarize research results. They can give you links to articles. They can do all sorts of things. And so this is starting to look like maybe we're on the path to AGI, right? It looks like maybe we have something like the kernel of general intelligence. At the same time, I think it's no wonder that this has fueled the really dystopic scenarios and dire warnings that AGI will bring about the demise of humankind. So it's kind of obvious that not only are humans unique in using language, we're kind of uniquely powerful on the planet. We've outcompeted pretty much all other species to the point of causing the extinction of many. We've transformed the natural environment to such an extent that we might have triggered complete climate collapse, right? We even have a trash dump in outer space. So just imagine what an AGI could do. This is how the reasoning goes, right? An AGI would be as intelligent as a human, but because it's a computer and it's not limited by the human flesh, it would have nowhere near the limitations on memory, processing speed, or computing power, right? If humans have such destructive power, despite our limitations, surely people think an AGI would have even more. And then there's this reasoning that, just as we have the intelligence to produce AGI, maybe superintelligence, machines that are even more intelligent than we are, well, those machines could produce more machines that are even more intelligent than them, And ultimately, we'd get this kind of intelligence explosion. And just imagine the destructive power of those kinds of systems. So this is where the debate is at. Here comes the manifesto. So the problem, in my view, is that pretty much everyone in this debate is operating with a misguided conception of AGI. There are many different misconceptions, but they're all operating with misconceptions. And you might say, who the hell is she to say that? She's, not a computer scientist. I've never built a robot. I've read now quite a bit about how these systems are designed, but I couldn't make one. So who am I? Well, I happen to know a lot about human intelligence, and AGI is widely agreed to be defined as a machine that's at least as intelligent as a human. And it seems to me that the conceptions of AGI that are guiding the current efforts both to develop AGI systems and to assess the risks and benefits are based on mistaken philosophical assumptions about the nature and measurement of human intelligence, particularly what it takes to understand a language, which is kind of central to our ability to reason, to plan, or possess any of the cognitive skills that are distinctively human. And this, if we look more closely, so the manifesto is like, the call to action is computer scientists need to pay a lot more attention to the other cognitive sciences, philosophy, psychology, cultural evolution, and anthropology, and linguistics. Because when we look at that, this calls into question both the existing AGI timelines and the assessments of the risks and benefits of AGI. Okay. So what I'm going to argue is that, in a sense, or an implication of my argument is that what's really likely to occur in the near future is that a tech company is going to produce what they call AGI, but which is really, in fact, what I call ersatz-AGI. A system that is extremely good at mimicking human behavior, but just doesn't have the underlying cognitive capacities that are constitutive of distinctively human intelligence. And I think we should be very concerned about the risks associated with ersatz-AGI. And also, once we're clear on the capacities of current systems, near future systems, possible systems, then we can have a much better account of the risks and benefits of developing various new technologies. Okay, so that was the manifesto. Let's get into some details. If there's anything confusing, by the way, please just interrupt me if there's something I need to clarify. Okay, so the first issue has to do with the importance of behavior. So, though it's true, it's been widely acknowledged that the term AGI means a lot of different things to different people. But still, it is almost universally accepted among computer scientists in particular that AGI is to be defined in terms of and measured by a system's performance on certain tasks that are specified. So we see this is, evident, of course, in the Turing test, right, which measures a system's ability to think by looking at its linguistic behavior. We also, I think, see it in pretty much all the benchmarks that are used to assess the capacities of artificial systems. So, for example, the A12 reasoning challenge, or is that AI2 reasoning challenge, ARC benchmark consists of a whole bunch of grade school level multiple choice science questions like, which item below is not made from a material grown in nature? A, a cotton shirt, B, a wooden chair, C, a plastic spoon, D, a grass basket. So these kinds of questions are given to an AI system. Some of them are easy, some of them are hard, and that's supposed to be a way of probing the capacities, the underlying capacities of the system. And the thought, I think, behind this is that, look, for a child to answer this question correctly is going to require that she understands the meaning of the sentence, obviously. If she didn't understand English, she wouldn't be able to read the sentence or answer it. She has some knowledge of which things are grown in nature, which are artificially manufactured, and she has the capacity to reason on the basis of her knowledge to come up with an answer to that question, even if she's never specifically answered that question before. And the problem is that even if that's true in the case of humans, it's just not the case that it doesn't follow that this is true in the case of AI systems, right? That in order to answer the question, an AI system also has to use understanding, knowledge, and reasoning. Indeed, even in the case of a human, right, whether or not one manifests understanding, knowledge, or reasoning in giving a particular answer on a test depends on how it is that one arrives at the correct answer. Right, so imagine that you find out, you're told today, you're going to sit a test tomorrow, or maybe you need a little bit more time, but you're going to sit a test that's entirely written in Pali, which I assume you cannot read. And it tests knowledge of some lost Pali text that I'm assuming you don't know the contents of. But you can memorize a cheat sheet that's written in English that just tells you first question, third answer, second question, fourth answer, and so forth. And so you memorize the cheat sheet and you go in there and you get 100% on the test. That doesn't show you understand Pali or know the contents of the Pali text, or that you manifested reasoning in giving the answers that you did, or at least not the kind of reasoning that you would expect. And of course, the same goes for an AI system, right? Whether or not it manifests understanding, knowledge, or reasoning when it gives certain outputs depends on why it gives those outputs, right? What goes on internally that explains why it gives the outputs that it does. So one question is just whether it's producing the outputs that it does has to do with any intentional states of the system at all, right? We can distinguish between explanations in terms of a system's understanding, its beliefs, its desires, versus what are called engineering explanations of behavior, right, which just explain it in terms of the causal phenomena that underlie those capacities. So this is true in humans as well. You can describe some behavior of mine as the product of my beliefs and desires, but you could also describe it in purely engineering terms, in terms of patterns of neural activation in my brain, the way in which that triggers the contractions of my muscles and so forth, and how that produces this kind of physical output. Those explanations are called subpersonal explanations or engineering explanations of behavior. And there are many, many aspects of human behavior, just like the physical movement of human bodies, that are explained in these ways, and in fact have no intentional explanation. So if I sneeze, for example, there's only going to be an engineering explanation of why I do that, no intentional explanation. And so in the case of LLMs as well, we need to be able to determine what kind of explanation is the right kind of explanation to give, right? Is it just a mechanistic engineering explanation, or is there an intentional level explanation as well? And second, we need to determine what sort of intentional explanation, if there is one, needs to be given of its outputs. And it's only then that we can determine whether an AI system really understands or knows or reasons. So the bulk of this paper from now on is going to really concern language understanding, because partly because that's, I think, taken to be one of the gold standards of intelligence across the board, but also I think it's really fundamental to what makes human intelligence special. You can ask me about that later. I won't have that much to say about it here, but I think it's very important. So the way I'm going to investigate this is I'm going to ask, basically, do large language models actually understand language? This you might think of as like the first step towards AGI, and one of the primary reasons why people think that LLMs really are on the path to AGI. So the current front runners are LLMs, because they process natural languages so fluently. But it seems to me that to ask, for reasons that I've just given about the sort of the the lack of probative value that looking at pure behavior just on its own gives you is that we need to ask certain questions, certain fundamental philosophical questions or questions in the cognitive sciences more broadly, such as what is a language and what does it take to understand one. And so here's a very, very brief overview of what I think the answer to this question is. So to begin with, public languages, right, such as English or Swedish, are social objects. They're used as conventional means of communication by a group, a community of linguistic speakers over some period of time or in some region of space. Now, in a communicative exchange, a language user uses a linguistic expression, either a string of phonemes or orthographic marks, right, characters, sequences, in order to communicate something. And communication succeeds only when the user's audience understands the linguistic expression that the user of the expression meant to communicate with it. So there has to be some kind of understanding of meaning in this exchange. But unlike natural signs, right, like smoke being the indication of fire, or even animal communication systems where there's a direct indication relation, right? If a vervet monkey makes a particular kind of vocalization, that indicates the presence of a leopard, right? So these are, in a sense, natural signs that have this kind of natural correlation indicating the things in the environment that they're about. But language doesn't work that way, right? If I use the word leopard, that doesn't indicate to you that there's a leopard present in that same sense. Rather, linguistic meanings work by virtue of linguistic conventions. So the conventions govern how we interpret particular uses of linguistic expressions on particular occasions of use. And communication succeeds when the two parties to the exchange agree or converge in their interpretations of the utterance that was used in that exchange. So we might say that the true or correct interpretation of a public language or some expressions of the language is the interpretation on which the users of the language converge. So one of the branches of the cognitive sciences that I think we should pay more attention to is formal semantics. This is a kind of relatively new science. It's kind of grown up over the past, 4 or 5 decades, but it's been extremely fruitful in giving an account of public language meanings. It can be viewed as the science of meaning. And so I think what formal semanticists typically do in their day jobs is they go around and they find classes of expressions of English or Tagalog or whatever sentences of a language, and they attempt to come up with some account of what their true interpretation is. This can get very complicated, but the basic idea is that they construct an interpretation that consists of some postulated universe of entities or domain, a specification of the types, the semantic types that the different expressions belong to, so whether they're names or predicates or sentences or quantifiers, logical terms, and so forth. And then there's a kind of postulated assignment function that assigns extensions to the non-logical vocabulary of the language from the objects in that universe. The universe, in some cases, is going to be objects in the world, but in other cases, when we talk about fiction, it might be fictional objects, right? So these are the universe is just something that's used as a way of specifying the interpretation. And so there's a characteristic way in which these assignments are made, right? Names are assigned individuals in the domain. One-place predicates are assigned sets of individuals, two-place predicates, sets of pairs, and propositions. This is the philosophical term that's used for ways the world might be, right? So sentences are assigned, or at least declarative sentences are assigned propositions as their meanings. They specify the way the world would have to be for them to be true. And finally, there's a set of compositional functions that tells you how you get from the parts of a sentence, the meaning of the parts of a sentence, to the meaning of the whole sentence, depending on the syntactic way in which that sentence has been constructed. So basically, for an individual user of a language, right, formal semantics studies the public language. For an individual user of the language to understand the meanings of some fragment of it, she has to have the correct interpretation of that set of expressions. And then the question arises, what is it, or how is that knowledge encoded, right? How do we know, what is it to know this, the correct interpretation of some set of expressions? How is that knowledge encoded in the mind? And there's two traditional views. Oh, sorry, I missed that. There's two traditional views. Oh, wait. No, there it is. One is the theory view, according to which, roughly speaking, the theories that formal semanticists put together when they give an interpretation of some class of sentences that you might think of as a semantic theory, that is literally symbolically represented in the minds of speakers. Right? It takes the form of beliefs, propositional attitudes, or attitudes with propositional contents, beliefs about what expressions mean. It's sometimes described as metacognition in the psychological literature, right? It's higher level cognition about the meanings of expressions, beliefs about what expressions mean. The thing about propositional attitudes is that they're typically accessible to consciousness and can be expressed using language. The practice view holds that knowledge of meaning is more like knowledge how, so knowing a skill, being able to use linguistic expressions appropriately in a way that conforms to their correct interpretation. On this view, interpretations are not really represented explicitly in terms of propositional attitudes or beliefs with propositional contents. And interpretations may not even be accessible to consciousness, but they're sort of manifest in dispositions to behavior, or they're constituted by dispositions to behavior. So ultimately, I had initially hoped that I would be able to just take one of these views off the shelf and apply it to LLMs, but I don't think either of them is accurate, and I'm going to present a different view, but because these are the views that are adopted primarily in the cognitive sciences, I'm going to start by considering the prospects for LLMs to understand or have correct interpretations of meanings on the assumption of one or other of these views. So first, the theory view. This implies that interpretations are encoded explicitly. So you might think, what kind of evidence could we have of this, that LLMs encode interpretations explicitly? Well, since propositional attitudes are typically expressible using language, we might just ask an LLM to define terms or train it on some kind of tasks involving recognizing or devising meaning postulates. I think some of these might be analytic. I haven't put an example there. Like you might think, a vixen is a female fox. Could be a way of testing whether it understands, like, does it output this? You say, what does vixen mean? And if it says a vixen is a female fox, then that might be some evidence that it understands the meaning of the term vixen. Or you might train it on, this is more like what actually is in the content of formal semantic theories, what you might call meaning postulates. Socrates denotes Socrates. Thinks denotes the set of all and only thinkers. Socrates is true if and only if Socrates thinks. Sorry, Socrates thinks is true if and only if Socrates thinks. But like even if we trained LLMs to perform perfectly at these kinds of tasks, this wouldn't constitute evidence that the LLM correctly interprets the meanings of the expressions, because whether or not it constitutes evidence of knowledge of the correct interpretation depends on what the LLM understands the meaning postulates to mean. Right? Like if it's defining vixen in terms of female fox, what does it mean by female and fox, right? It's only if it has the correct interpretation of those expressions that the analytic statement is going to be evidence of a correct understanding. sorry. And the problem is that there are infinitely many interpretations, infinitely many possible interpretations of any set of linguistic expressions. So for example, take the expression number. This expression picks out the infinite set of all and only numbers. Given that that's the case, there are infinitely many alternative interpretations, right, according to which the expression number picks out some finite set, only the numbers up to some value, n. So this derives from the fact that linguistic meanings are abstract, right? They can have infinite extensions. And linguistic meanings are also generative, right? A finite set of meaningful simple expressions can systematically combine to generate an infinite set of meaning complexes, right? So for example, you can take any two meaningful sentences, declarative sentences, and conjoin them using and you'll produce another meaningful declarative sentence, which you can then combine with another using and. So because these expressions work in this generative way, because they're recursive, there's sort of no length of meaningful, there's no upper bound to the length of meaningful conjunctions. And so as a result, you can construct an interpretation of and, any number of deviant interpretations of and, where it only permits, say, n number of conjuncts. And so we have all these interpretations of linguistic expressions that the LLM might be using in its meaning postulates. And if we're rational, because all of these are compatible with the evidence, right? The LLM is only producing finite outputs, right? Only finite numbers of conjuncts using and. It's only producing meaning postulates. Even if you tried to test it on what are all the numbers, at a certain point it would have to stop. And so it looks like since there are infinitely many such hypotheses, we should accord equivalent probability to all of them. And that means that the probability we assign to the hypothesis that LLMs actually correctly understand, given that they produce some meaning postulates, is extremely small. So these considerations, this kind of underdetermination problem, also tells against the return to sort of classical computational models of cognition, or the development of what's called neurosymbolic AI. So the classical computational model, also called good old-fashioned AI, was the type of kind of paradigm in the development of AI systems that was used very early on in the beginnings of research into AI. So symbolic systems are basically systems that are programmed with certain rules for the manipulation of symbols. And the classical computational theory of mind correspondingly holds that human cognition is fundamentally the kind of manipulation of symbols in accordance with some innate rules. So the early computers were symbolic systems. LLMs are not symbolic systems, but people who are kind of inclined to adopt the kind of theory view of the mind, of the human mind, often think that, well, the answer to the problems with LLMs is to just encode the right rules, right, into the system. Just program them with these kind of some symbolic rules, a bit of symbolic architecture to produce these hybrid models that are both like LLMs, which are neural networks, and have these symbolic elements. But the problem with this is exactly the same as the one with the meaning postulates. Because if you program a system with some rules, you input some symbols in the system and then define algorithms for manipulating them, that has to be done in some programming language or other, say Python, right? And we might understand the symbols to mean something, but for the system itself to understand them, it has to understand what those rules are telling it to do. So it has to have an understanding of the semantic rules or the understanding of the symbols themselves, even if they're written in a coding language, in order for that, the fact that it implements those rules, to be evidence of understanding. The problem of underdetermination, I think, also arises for the practice view, right? This is already kind of evident because though LLMs are, as is widely known, trained on huge amounts of linguistic data, it's still finite, right? So according to the practice view, the fact that a system understands, say, the word number to denote an infinite set of numbers, or to understand the meaning of and, is just determined by its dispositions. But the problem with these systems, this kind of view, is that because all of the inputs, outputs, and data on which LLMs are trained have a kind of upper bound, right? It's not trained on infinitely long conjunctions. There's a sort of there's a token context window. There's just an upper bound to the number of string sequences of tokens it can process. And so there's no way that its dispositions could settle which of these infinitely many competing hypotheses about what LLMs mean is true, right? So it leaves a huge space of hypotheses open, all of this evidence of their dispositions. And so from our perspective, we should accord a very low probability to the hypothesis that they correctly interpret, just based on the dispositional evidence, that they correctly interpret, say, the expressions of English. Okay, so some people diagnose the problem with the practice view as stemming from the fact that LLMs are typically trained on purely textual data, that they have no access to the objects in the world that those bits of text are about, like shoes, ships, sealing wax, right? So for example, Bender and Collar and Murray Shanahan and various people have pointed to this as the sort of problem, the reason why just practice isn't sufficient. It's because it's purely linguistic practice and no behavior that involves, no nonverbal behavior, no interaction with the world, and no evidence that comes from, pairing hearing or reading linguistic expressions with observations of the kinds of things that those expressions are about. So this is a kind of common worry, but it sort of suggests a kind of solution, which I think many people are working on, which is to construct these hybrid systems, right? Combine LLMs, which are trained on language, with image processing systems that are trained on streams of image-related information, and maybe put the whole thing into the head of a robot and get the robot to interact with the world. So, for example, some people have done experiments where they've had an AI learning on the basis of they put like a video camera on the head of a young child learning a language, and use those signals, so both the kind of auditory and the visual input into the camera that accompanies the child's learning of language, and then see how this, and then have an LLM train on these inputs, and with some degree of success, but I think the success is limited. And the reason is that there's a problem with this whole approach, right? This is a very common, broadly empiricist approach to language acquisition, and the fundamental problem was acknowledged by Fodor a long time ago, but it's that associations between linguistic expressions and perceptual representations, if we think of that as understanding the meaning, just having these associations, that's got to be mistaken, because the contents of perceptual experiences are concrete in a certain sense, whereas so they're iconic representations, whereas the contents of linguistic expressions, their meanings, are abstract. So here's an example to illustrate. So compare the image, this is Margot, the image of Margot sitting with the sentence Margot sits. So the sentence contains these discrete units, right, with abstract contents, right? The name Margot denotes Margot. In abstraction from any of her properties, the predicate sits denotes the set of all and only those things that are sitting at the time of utterance, or at a context, irrespective of which instances, right? It doesn't really encode any information about who is sitting. And then these two combine in the sentence, by this process of function application where sits is a function from entities to truth values. Like X sits is true if and only if whatever is denoted by the name that is put in the place to specify, to determine the denotation of X, sits. Okay, so that's how language works. It has these bits that integrate to give the meaning of the whole. But the image is not like that at all. It doesn't work like that at all. There's just one part of the image, right? This whole part, right? I don't know how to do this little dot thing. Oh, there we are. That doesn't work, did it? Okay, anyway, this part denotes, it represents Margot, the individual, as an instance of several of her properties simultaneously. Like she's sitting, she's furry, she's black, she has a cat-like shape, etc. So all of these properties are represented simultaneously by the same constituent. There's not two things, one that represents Margot and the other thing that represents her as sitting. It's just one thing that represents both of these things. And so you can't take them apart. You can't take bits apart of an image and put them back together. And the problem is that then there's just nothing, you can't get this kind of correspondence between just this element, Margot, what that means, and any item in the image that doesn't also encode the information that it sits. So meaning just can't consist in associating these sentences with these kinds of sensory experiences. I realize I'm running out of time. And so let me just try to very briefly say something about the view that I think is correct. So according to the view I propose, which I call the model view, is that understanding is not having a theory, it's not having an ability, it is to have a model of a specific kind. It's a model that targets or represents the semantic properties of the expressions of the language. That's what it aims to represent directly. So it's a meaning model. And when you understand, like that's a success term, then you have an accurate representation of the semantic properties of the expressions of the language, or that part of the language that you understand. So the term model has many different uses. In fact, the thing that I've been calling an interpretation is also sometimes called a model, but I call it an interpretation just for clarity. But so the sense of model that I have in mind is that of a kind of representational model like those that are used in the sciences. So here are some examples of scientific models. There's this kind of, I don't know if it's really balls and sticks, but anyway, this like concrete model of DNA. That's Watson and Crick's. And then Schelling's model of segregation in society. This is a computational model, and that represents the kind of distribution of, I think it's assumed, ethnic or racially typed individuals in a society. Okay. Now I've lost my place. Here we are. Okay, so how do models work? Well, so first of all, they represent individuals in the domain, whatever their target domain is, by having representational units that stand in a one-to-one correspondence with them, right? So the specific nucleotides are represented by these structures on the sides, and individuals in the society are represented by locations on the grid, or positions on the grid. And then models represent properties or relations by virtue of having those representational units stand in properties or relations that are in some way systematically related to those in the target domain. Right, so the bond, so these two nucleotides are related by a bond. Well, that's represented by the stick in the model. It's the bond between them. And the relation of being a neighbor of is represented in the Schelling model by being adjacent on the grid, right? Adjacent on the grid, that instantiating that property of being adjacent on the grid is a way of representing neighbor relation in the society. Okay, so, but just having this, so these kinds of systematic relations, they're really cheap, right? They come very cheap. I can put together, a bunch of people, 8 people, and say, like, this is a model of the solar system, right? So any 8 people are, in a sense, a model of the solar system if all that matters is that there's the right kind of objects and that they, satisfy some properties that are satisfied by the system. But so in order for these models to represent, there has to be some kind of intention on the part of the modeler. In the scientific case, of course, those are like explicit intentions, but in the case of meaning models, they are implicit intentions. And basically, these are determined by the way in which we interact with the language and the world. So a meaning model is a representational device that's intentionally directed towards the semantic properties of the language, or the expressions of the language. And so it contains representational units, that is, concepts or thoughts, which are intended to stand in a one-to-one correspondence with the expressions in the fragment of the language. Right? So we intend for our names to correspond to, we intend for singular concepts to correspond to names, general concepts to predicates, thoughts to sentences. The one-to-one correspondence is also intended to preserve semantic properties. The basic idea is that this is achieved by the fact that, when you hear a name, you construct a concept in your language of thought that you take to stand in for the name, right? It's the model, it's the element of your mental model that stands in for the name, that corresponds to the name. And then you assign it several properties. It plays a certain kind of functional role in determining the truth conditions of thoughts in which it occurs. It is assigned to a certain kind of category. You take it to denote a certain type of entity, right? Either an individual, you might think your singular concepts denote individuals, right? And that's going to have various effects on your behavior, right? So for example, it'll be manifested in the fact that, the fact that Aristotle is a name for you, or you implicitly take it to be a name, is going to be manifested in, for example, your use of the singular when you construct sentences using the name Aristotle. But it's not just that behavior that is constitutive of its being a singular term. Rather, what matters is the way in which it combines with the other concepts to generate truth conditions. Okay, so So I think this solves the problem of underdetermination. And the first reason for this is that just has to do with the distinction between the way in which theories represent and the way in which models represent. So the sorts of theories that are devised by formal semanticists, they're generalizations from and idealizations of the semantic facts, which are determined by the convergent meaning models of users of a language. Right, so the sort of specification of general rules, the kind of symbolic representation in a set of sentences that take the form of a theory, is in a certain sense always going to be some kind of abstraction, generalization, and idealization from the kind of facts on the ground about the meaning models. Incidentally, you're going to get that too in science, right? You get that because, as I pointed out, observations or perceptual experiences have concrete contents. So when you devise a general scientific theory, you're also idealizing and generalizing on the basis of the contents of your experience. So it's no more illegitimate for linguists to be formulating general rules that describe, for example, the way in which you determine the meanings of a whole sentence based on the meanings of its parts and its mode of composition. But we just shouldn't think of those as literally written in the mind any more than we should think of the laws of nature as being written in some kind of book of the world. Okay. I'm going to skip this and get on to the next point, which is that I think LLMs do not model meanings. Right? So this is the final argument for why LLMs don't understand. So if this is the correct account of what it is to understand a meaning, it shows that LLMs don't do that. And the reason is that LLMs, this is another term, another use of the word model, LLMs are data models. They are statistically processed summaries of the data, of the raw data on which they're trained. And the raw data on which LLMs are trained and process, that the data that they process is not encoded, doesn't encode any kind of semantic information. So the first step, if you're going to train an LLM, is you have to take the linguistic expressions in a corpus and you have to break them down into what are called tokens. So tokenization takes these expressions and converts them and gives them, a token ID. Now you might think, so one way of going about doing this is just like start a priori, but given our understanding of English, our human understanding of English, you just assign a token ID to every kind of morpheme or word, right? The smallest units of significance in the language. But that turns out to be, that makes the token library far too big, and it's difficult for LLMs to process. And so the way in which tokenization is carried out is, it's also a kind of learning mechanism. So the tokenizer is fed this kind of sequences of characters, and it assigns first a token ID to each character. That's including punctuation marks and spaces, right? It assigns a number to each one, and then it looks back in the text to see, which sequences are most common. So EE will occur frequently in the text, but not AA in an English text, right? And so it'll assign a token ID to a number to one of those, and so on. And the average length of tokens is about 4 characters, right? So there are many words that don't appear. Also, token strings include spaces and punctuation marks, which are not words. And so the tokens just don't correspond to words or morphemes. So that kind of semantic information, which the units of significance are, is not encoded. And secondly, when the LLM processes information, it gets these tokens as input. Those are encoded in a vector. The vector represents the position of each token in the sequence, right? And then these vectors the sequence of numbers are subject to a bunch of mathematical operations that occur in this layer of the model. And those mathematical operations basically involve comparing the 2 tokens in the input stream with, say, either another token in the input stream and the tokens in the library to see how common they are or how well correlated they are in the corpus of the text, right? So the attention weights are assigned then to specific tokens in the token library, and the LLM then outputs, what it outputs first is a probability distribution over all the tokens in its library, from which so it says, what is the most likely what is the most likely continuation of this sequence of text? Or what is the most likely replacement for the masked token in the sequence? And then it outputs that. And it learns by just being told what the true account is. It calculates a loss function, and then it goes back and adjusts the weights to sort of minimize the loss. And thereby it comes to have a kind of statistical model of the kind of proximity relations or correlations between particular tokens in the text. And that is the basis of which it produces its outputs. Okay, now I'm really running out of time, right? So let me just say briefly, I think the fact that LLMs don't understand language also implies that they lack a host of other capacities, right? So if they're just data models, then they're not able to represent, for example, the truth values of sentences in the corpus. And if they can't do that, then they can't represent logical relations between truth values. They can't use logical terms as operators on truth values. And they don't have concepts with abstract language-like contents. So I'm going to just skip this, resisting the argument. We can talk about that later. And just say very briefly that this is kind of coming back to some of the moral questions. So I've argued that LLMs don't understand natural languages. And given the reasons why they don't understand, it seems to me pretty clear that the techniques that are currently being used in the tech industry to develop AGI are really kind of missing the point, right? So just having more data, training them on more data or more refined data, or giving them more computational power isn't going to make a difference, because a better data model is still just a data model, right? It needs to be trained on the right kind of data in the right kind of way. And so it also suggests that we're moving towards perhaps ersatz-AGI. And I think that there's both good news with this and there's bad news. So the good news is that it's likely that the kinds of systems we're developing are not going to be AGIs. They're not going to possess agency. Right now, an LLM just sits there until you prompt it, right? Just more of the same is not going to give you an agent, a true agent that's going to act independently and spiral out of control. So we can be calm about that. Moreover, if we pay attention to what LLMs and other similar models are very good at, right, which is constructing highly sophisticated models of data, we should steer our research in that direction, right? We should have more systems like AlphaFold, right, and focus on systems that can be used in a way that will support the scientific research that we are, as humans, engaged in, rather than hoping for systems that are just going to go off and solve all our problems for us. The bad news is that there are risks associated with ersatz-AGIs. They're bound to be biased, right? Because they're data models. They just summarize the data that we give them. If there are biases in the data that we give them, they're going to produce biased outputs. That's just not going to change insofar as they are data models. They're unreliable. There's this problem of hallucination that many people may be aware of, where they just output falsehoods kind of bizarrely. Like ChatGPT couldn't tell you the number of D's in the word DeepSeek. It said 3, 5, 7. So these kinds of things are just very well explained by the fact that they're data models. But there's no way we can prevent them from doing this using the existing techniques. And they're actually very difficult to control for this reason, because they're data models and they don't produce their outputs on the basis of beliefs and desires of the sort that we attribute to them, which makes them, in fact, very difficult to control. So, for example, there are these problems with LLMs producing information that's dangerous, that's harmful, telling teenagers how to commit suicide, for example. And people try to put in some kind of guardrails to prevent them from doing this. It's incredibly easy to get around them, right? So they're very difficult to control in that way. And so this is something that we should really be worried about. But it's important to worry about it in the context of understanding what these systems are like. And the bad news, I think, is that many of the dystopic scenarios that actually have been produced on the assumption of AGIs, well, they're actually dystopic scenarios to do with ersatz-AGIs. So I won't go into the details. I'll tell you about it later, but it seems to me that generally speaking, all of these cases we worry about systems that are really, really smart, like smart robots, they can calculate stuff. They're really great at scientific knowledge, but they have no moral knowledge at all. They're sort of like weirdly fixated on certain goals that they've been given, or they just can't reflect on anything to do with morality. And it seems to me that this is just a kind of misunderstanding of what human intelligence consists in, which is very general, right? Like if you can acquire scientific knowledge, you can acquire knowledge of value. If you can reason instrumentally, you can reason morally. And so there's sort of, it seems to me, at least some kind of hope in the case of AGI that we might be able to build systems that are genuinely capable of moral reasoning, whereas in the case of ersatz-AGI, the risks of these systems that have these very bizarre capabilities in one domain, but not in the moral domain, are much more severe. So I leave you with that sort of bad news, good news.
Thank you so much, Anandi. Now we open the floor for questions. And since we're a multidisciplinary audience, please say your name and your discipline and raise your hand so I can... Ori, you can start, and you others keep your hands up.
Thank you, Ori, philosopher. So actually, the question that I wanted to ask is precisely on the on the picture there on your last slide. So I mean, you didn't say anything about how humans meet these sort of tests of the different views, and I mean, I'm sure you have an answer to that. But I was just wondering why, or can you say something brief to explain why these sort of problems also don't just should make us skeptical that humans understand language, which I guess would be a reduction of these of these views.
Yeah. So I mean, this is kind of what I skipped a bit quickly through, but so I think that the model view is an account of how we understand, right? And so, for example, in the case of grasping the understanding that the term number has an infinite extension. So in the case of models, because models are not like theories and they represent by instantiating, by having units that instantiate properties, the absence of a property being instantiated, like the fact that a model doesn't instantiate some property, is sufficient for it to not represent that property in the extension. That's not true for linguistic expressions, right? Linguistic expressions are, so the theory, for example, of the interpretation leaves it open. Like if you think of the interpretation as a theory, it leaves all these interpretations open. But if you think of an interpretation as a model, then you have, for example, in the case of number, the expression number is associated with the concept number, and that is assigned some extension in this universe of placeholders by the individual language learner. And what does that mean for that extension to be infinite? Well, it's not like there's like an infinite number of sort of representational units in one's mind, but rather that we have a way of generating. There's a way of generating the extension, right? You take a number, add one to it, and then you generate the extension in this way. And the fact that there is no element of the model, there's nothing there that tells you to stop at a certain point, that's what determines that there is no upper bound to that operation. It's not that I am disposed to do that, to keep adding one. I'm not. I'm going to stop at a certain point. I have other things to do, right? So it's not the disposition that determines this. It's just the fact that the elements of the model relate to one another in that way, and there is no representation in the model of an endpoint. that's how I think, that kind of problem can be solved if we view interpretations as models rather than as dispositions or as theories. Does that help a little bit?
Yeah, sure.
And then, the other part that I kind of skipped out on is that these kinds of accounts of cognition, generally speaking, they're accounts of what's going on in the mind, and that's kind of in some sense unobservable. So we're talking about unobservables, and how do we determine whether our theory of these unobservables is correct or incorrect in the case of a system? And I think in the case of, generally speaking, in the sciences and in the cognitive sciences as well, the way we do it is abductively, right? We formulate these hypotheses, we give this kind of account of what's going on in the unobservable aspects of the system, and then we evaluate those as the best explanation. We try to find which is the best explanation of the behavior. And I think if I had time, I would just go into more detail and argue that the model view provides the best explanation for human linguistic and non-linguistic behavior. So in the case of humans, but the sort of data model hypothesis, right, the hypothesis that LLMs are data models, gives a much better explanation of the totality of evidence in their case as well.
Yes, okay. So now Marcus.
Thank you. This is very interesting. So I was thinking about other ways of defining AGI, perhaps. It's a notoriously murky terrain out there, and everyone offers their own definition. So, OpenAI, for instance, suggests that AGI is technology that can perform any economically valuable task that is currently done by humans, which is it's problematic definitions for many reasons. However, so it opens up for the question of whether focusing on the language aspects of AGI perhaps reflects your interest in philosophy of language, whereas others would focus on other kinds of AGI definitions, and they would say that, we can avoid all of your problems because AGI is actually defined in this way. So, for instance, it seems to me that if we don't have to adopt the OpenAI definition, but we could use a similar model where we say that AGI is about performing human tasks as well as people, not necessarily economically valuable ones. But so, for instance, I could be emotional support for a friend. I could offer emotional support for a friend. I could probably pretty easily fake that without actually listening to my friend. I could just and offer a few pieces of advice. And that's precisely the point of the old ELIZA chatbot example, right? You can very easily construct a therapeutic chatbot that just mimics or mirrors whatever the patient says. And couldn't someone say that this is sufficient for AGI? So the chatbots, without actually understanding what they're doing, could still offer sufficiently good imitations of what humans are doing. And that's enough for us to say that there's AGI there. The basic question is, why should we go with your understanding of AGI rather than some other understanding, I guess. But
so one thing is that I think this is to some extent, yeah, sure, fine. We can just invent terms. I call that ersatz-AGI, right? And so that's the term I prefer to describe a system that doesn't really understand, but just produces behavior that mimics that of a system that understands, at least in many cases. But I think that, so one danger to saying, oh, well, that's just AGI, is that I think it leads us to be misled, both in our explanations of the way in which that system is going to behave, right? Because we think that we can apply ordinary intentional explanations to its behavior. And then it's like really difficult to explain why it is that it produces these really weird responses. Like in the therapeutic case, for example, these systems that have been, telling teenagers or encouraging teenagers to commit suicide, which I think resulted in a death, or telling teenagers how to safely self-harm, things like that. I mean, this is not expected from the model, right? And you wouldn't expect it from a trained psychotherapist, right? And so if we're saying, well, it's an AGI and it's sufficient that it mimics human behavior in certain cases, then I think we miss out on these risks, right? Because these risks are very easy to see if you recognize that it's just a mimic, that is really just a data model, because that explains this kind of unreliability in the results that are going to come out. And maybe we won't launch these systems, right? If we recognize exactly how they work and how, given the way they work, we're not going to solve those problems. So that's one reason why I think it's better to be clear about the distinction between an AGI in the true sense that I want to specify and this kind of ersatz sense. If we do that, then sure, we can talk about ersatz-AGI. And we should actually talk a lot about ersatz-AGI and the risks associated with those technologies.
Now we take a question online. Andreas Körling.
Thank you very much. First of all, thank you for a very interesting talk. I think I wrote a question in the chat, and I think you, to some extent, answered it, so I'll slightly rephrase it. But before that, I want a clarification. When you say intentionality, is it in the Husserlian phenomenological way of intention that you're referring to it? Or
Not
is it
really. I mean, I'm using the term as it's come to be used within kind of analytic philosophy of mind, which is intentionality just refers to, generally speaking, mental states that represent or about something or other. And so an intentional explanation will appeal to a system's perceptual experiences, her beliefs, her desires, and so forth. So that's what I take to be intentional explanation. Yeah.
Thank you. And then for my actual question, how do you see the use of AI in relation to discourse and hegemony, with sort of reference to Laclau and Mouffe and such writers? Because certainly AI is subject to the largest investments I think we have ever seen, and it's not the global South that is investing, and so on and so forth.
I mean, I think I have lots of thoughts about that, but it's not clear whether they relate to the stuff that I was saying here.
No,
but I mean,
that might be true. Yes.
I do think that. I mean, one thing that I think that is really unfortunate is that it's basically private, the investment into AI, and so it's not really constrained in the same way as publicly funded technologies would be constrained, or might be constrained by the right kinds of governments. So, I mean, one of the things that I kind of skipped over was the sort of deployment of AGI or ersatz-AGI in all sorts of different social settings. I think maybe worries about ersatz-AGI taking over jobs. I'm not sure whether that's really as worrying as some other contexts, which I think are very worrying. So, for example, the integration of AI systems that are like kind of ersatz-AGIs that mimic human behavior into, for example, the public sector of democratic societies raises questions about the kind of fundamentals of democracy and how those can be upheld if the agents of the state aren't genuinely capable of, acting for reasons or following the law. They might be acting in a way that accords with the law, but in some cases we care about our agents of the states actually following the law, and that might require understanding the statements in which the laws are framed, or acting on behalf of the people is another thing that might be called into question by ersatz-AGI.
Thank you.
Okay, my name is Per Kraulius, and I was doing biomedical research before I retired. I'm kind of I think it's fascinating to see that trying to discuss about general intelligence in an evolutionary context, because it's pretty clear from latest research, 20, 30, 40 years, that intelligence in humans is intimately connected to the social, the moral universe, the intentional universe, interactions, activities, and how things have developed during evolution. So it seems to me that these approaches that you have been talking about, ersatz-AGI, and it looks a little bit like they never read Darwin. Are you aware of any approaches that think in serious terms of how evolution produced human intelligence and how that would apply to AGI, if we are interested at all in producing such AGI? I'm not sure we are, but how would evolutionary reasoning come into it?
So there are two aspects to the answer I want to give. The first is, thank you so much for asking that question, because there was a whole part that I wasn't able to talk about human intelligence, which I think exactly picks up on this. So one thing about human language use is that it's fundamentally cooperative and it's fundamentally social. And it seems to me that the correct account of the development of human intelligence actually builds on our capacity to communicate using language, which gives rise to or affords this kind of cultural evolution of a whole bunch of cognitive skills, like the ability to reason, and then all sorts of things like, solve differential equations, write haiku, whatever. But all this stuff is fundamentally a product of cultural evolution that fundamentally builds on the human capacity for language. And what is more quintessentially human than a capacity for moral deliberation, for having a consideration for others, right? So this is also something that is culturally evolved. So I think that that's absolutely, if we want to prioritize, as I think we should, in the development of AGI, prioritize the development of moral AGI, then this is where we need to focus, right? On the way in which cultural evolution produces moral beings like us. The second part is that, yes, there is a branch of computer science that looks at that does what's called evolutionary modeling, right? And this has been developed a lot in the context of games, for example, where systems are trained, right? You can train chess-playing computers by getting them to play against each other. And so they evolve strategies. Or you can construct a kind of virtual environment in which different agents have to compete for resources. And so you train that, so they sort of develop these strategies for solving those competitive exchanges. So that's a kind of evolutionary approach that has been adopted. But I think it's kind of problematic. It's too coarse-grained in a way. So for one thing, there's a limitation. These systems just are very simple. Their environments are very simple. The strategies reach a certain plateau and then, they don't get any further. None of them is developing anything like human intelligence or language or anything like that. But I do think that there's a way of combining potentially evolutionary models with some more careful modeling of the way in which humans learn language and the way in which we use language and cultural evolutionary models of how we transmit cognitive skills. So there's sort of like the technology is kind of out there. It's not a technological problem. So it seems to me in principle possible that one could construct AGIs that have these kinds of cognitive capacities and that participate in cultural evolution in much the same way that humans do. But it's a matter of bringing these together.
Thank you. So I put myself on the list. It's actually my first question was exactly Marcus' question. So like the artificial part, isn't that precisely the mimic part of artificial intelligence and to perform human-like tasks? So I was wondering if you could say, what would computer scientists and programmers, how would they work differently if they adopted your model view? Because I also see dangers with what you're talking about with moral AGI. Maybe it's better that they do these kind of more, mimicking tasks.
Yeah. So the first thing, I I take artificial to just mean, being an artifact. So being produced by the activities of an intentional agent rather than not, right? Okay, you could have some quibbles about God, okay, but I'm not going to go there. So be an artifact is something that's like the product of an intentional agent. Setting aside God, we are not artificial. Computer systems are, because they are produced by intentional agents like us. And so that's what I take artificial to mean in artificial general intelligence. And so I think, again, I guess the terminological question is just, sure, let's just be clear about our terminology. And sure, we can think about AGI in that way. Just be clear about what we're talking about. The second part of your question was like the moral risks associated with artificial general intelligence. I mean, I think certain risks are, or at least we have to think about them differently in that case, okay? Because, so one of the things with like the case that I had a slide on but didn't really discuss, this is Bostrom's paperclip maximizer. So you have an AI system that's just like single-mindedly wanting to maximize the number of paper clips in existence, and then he describes this scenario where we try to turn it off, and it kind of calculates that the probability that there'll be more paper clips will be lower if it gets turned off, and so it kills everyone, and and then I kind of think, well, if it's an AGI, why not just talk to it, like ask it, how great are paper clips really? Like if we started with that, right? If it really were an AGI, then presumably we could do the same kinds of things that we could do with humans. Of course, humans are pretty nasty sometimes. Like we do horrible things. And so, of course, producing systems that are like humans doesn't guarantee that they're going to be benevolent or morally wise. And I think that, again, there's a choice when we're doing this as to how much power we give these systems, right? How much agency we give them, right? Is it, is it possible to understand a language without giving them agency? Maybe it's not. I don't know. But I think that, so the questions we have to consider have to do with how much power we give them, not so much how we construct their cognitive architectures, right? Yeah.
Thanks. So now we have a question online. Per Norback.
Yeah, hi, Anandi. Very interesting talk. I would like to ask, I think the model view resembles early Wittgenstein, like Tractatus. And he went on then in a pragmatic view and, choose something more similar to the Turing test. I wonder, why should we require more from LLMs than superior usefulness? Like, why should we require something more?
So on Wittgenstein, I agree. Like a lot of these issues come from Wittgenstein. And I think the model view, though I think Wittgenstein got to the point of like seeing the problems with the theory view and defending something like the practice view, the pragmatic view, but not really got so far as he should have in seeing the problems with the practice view. And I think there are problems with the practice view in explaining human cognition, right? And I think the model view solves those problems with respect to human cognition. So I think that gives the best explanation of the totality of evidence that we have of human language use and capacity to conceive of abstract things, represent infinitudes, and so forth. So given that that's the case, if we want to know whether LLMs really are doing the same kind of thing that humans are, if they are understanding, then we just have to use the same kind of model of what that is to try to explain their behavior. And then the question is whether that model, that account, that hypothesis about what's going on is the best explanation of the evidence or not.
Okay, I have a follow-up. In my, I think that maybe AGI should be a part of us, be a part of human, like integrate in some way. I don't know how. And my question is: does AGI, per definition, must they be able to function without human input? Per definition.
I don't know. I mean, maybe there is a definition of AGI of that sort, but I would have thought that once you start down the path of thinking of AGI as a machine that's at least as intelligent as a human, and if you go down the path that I'm kind of pointing to, where that requires knowledge of language, knowledge of language fundamentally requires interaction with other language users. Like, there's no way to learn a language without interacting with other language users. If I'm right, because in a sense, you get the interpretation from the language of the community with which you interact. And if that's the case, then there's no real way you could have an AGI that's capable of understanding human languages, but that isn't integrated into human societies in the same way that other humans are. Like, it would have to learn from us initially, at any rate, and you might have then communities of AGIs that are communicating with one another using a language, but still, if language is fundamentally a social activity, then they have to be fundamentally social in themselves, right, in order to develop those, in order to just sustain that capacity for thinking abstractly, reasoning, and so on. They just have to be able, that has to come from language, in my view.
What a comment or new question? New. So we have a question in the back. Yes.
Hi, I'm Tanya. I'm a guest. I'm an art historian. Thank you very much for your talk. It reassured me a bit. I was a bit afraid when I recently listened to the Israeli historian Harari, who had said that in 5 years' time, the AI systems will think on their own and do all this and outwin us, So it sounded we have more time, at least. But I would like to use your expertise on a very practical question. I'm an editor for a journal, Public Art Dialogue, and we recently got in an article where we all were a bit skeptical. So we run it through the system, and it turned out to be 52% AI generated. So we asked them again, and they said, no, it's all ours. It's just we used grammar and suggestions for language and organization. So, I mean, this is something we all have to face with when we now edit volumes, when we publish. Very many colleagues already use these kinds of systems. So maybe you could say a little bit on what you think about us using this. Should we use them, and how should we tolerate this? Or is this something where we say, because we felt very left alone, and I would like to ask you.
Yeah, I mean, these are tricky questions, and I think probably one has to think case by case, right? It's very hard to give a general answer to specifically these kinds of problems. So, I mean, one of the problems with the kind of data models that LLMs are, like, once you pay attention to that, you realize that some of the problems that arise as a result of relying on them, for example, to help you write parts of text and so forth, are problematic. One of the reasons they're problematic is that, at least in certain cases, right? Like, so for example, when there's some bit of text that an LLM has only seen once or very rarely, it has a tendency to basically plagiarize. So this is the problem with the New York Times. There's this suit against OpenAI because ChatGPT, when prompted about some past event that only the New York Times reported, it just produces pretty much verbatim the New York Times outputs. So there's a serious worry about plagiarism in relying on AI systems to formulate bits of text in publications, because not only is there the worry about the authors using AI, but that, downstream, those sequences of words might have been plagiarized in a sense from some other source. So that's a serious worry, right? On the other hand, you might think, well, maybe it's just like spell check or grammar check or whatever, and like that's okay. And I think it's going to depend actually just case by case, right? What the facts are about those sequences of characters, right? Did they come from some New York Times article or did they not? Is it just akin to, using a grammar checker, or is it not? And I think, it just kind of has to be decided case by case, yeah.
Thank you. With the question, yes?
Yeah, thanks. I'm a human ecologist. I would like to go back to the kind of evolution sphere. I thought, or like arena. I thought that was really interesting, and I feel like in this talk, obviously there's a lot of focus on language, but I feel like the meaning model that you employ to describe human intelligence. If it's like based on an abstraction of perception, that is also, very embodied, which is also related to how evolution, like this evolution or cultural development of human intelligence. So I guess I was wondering with this, and also in that, I don't see how computer or data models will ever be able to have an embodied experience of their surroundings. They're kind of stuck in this world of language, which is granted an important part of human intelligence, but is not all of human intelligence. So I wonder if this focus on language also kind of makes us get lost a little bit in understanding what true AGI would be.
Thank you. I guess there's two things I want to say. So one is that I don't actually think of language as kind of abstraction from experience, because experiences have these kind of concrete contents. They underdetermine how you're going to abstract from them. And so you have this kind of underdetermination problem with all of these kinds of associative accounts of language acquisition, according to which, say, you learn the meaning of the word cat by having perceptual experiences of cats, because there's nothing in those the contents of those concrete experiences that determines how you should abstract. So rather, I think that what's key to human language acquisition is the ability to abstract kind of at the get-go, right? To recognize that this expression isn't just associated with this object, but that it has this semantic function of denoting an extension of which this object is an instance, but that doesn't determine, that doesn't determine the extension. It's this kind of hypothesis or this hypothetical model about the way in which it functions semantically that does this. And so in the case of language models, I think, so this kind of question about embodiment, so I don't think that you need to have perceptual experiences in order to understand meanings in this sense, that you need to pair the meanings with an experienced state of affairs or object in the world. But it may be that you can't really get the function, you can't really understand the function of linguistic expressions unless at least sometimes you have some access to their use in on concrete occasions. So, there's two aspects of meaning, right? There's the sort of standing meaning of an expression, but then there's also the interpretation of a particular expression on a particular occasion of use. And that might require embodiment, right? Not in the sense that we need to pair associations with, we need to sort of associate expressions with conditions in the world, but because we need to actually exercise our interpretations of our understanding of the meaning in order to interpret concretely what someone is saying on a particular occasion. And that might require embodiment, right? So, for example, you can distinguish between anaphoric pronouns, like as in Sally was here, she brought a donut, versus Sally was here, she brought a donut, right? So in order to distinguish that, you have to have some ability to recognize, the deictic use of that pronoun. So there are certain kinds of cases in which, embodiment matters, but not for that, not just by association.
Thank you so much, Anandi. So before you go, I just wanted to advertise the upcoming seminars. For 1st October, Nils Holtug from Copenhagen University will talk about identity politics, statues, and outgroup representation in art. And the 8th of October, we have Martin van Hees from Amsterdam, who will talk about assessing freedom back to Berlin.